Okay, today we're going to continue with a tradition, with the sessions that include topics that you already know. I think that most of what we're going to talk about today we've already discussed. Maybe not in this depth, but we're not going to get much deeper than what you already know. So we're just going to see some examples of string manipulations and text. And since all of your applications so far were console applications, you've been manipulating strings all along, and we've been seeing all kinds of examples of formatting strings and concatenating strings, and even we saw some examples with StringBuilder. So I don't think we're going to be touching much new stuff today, but it's formally to cover this topic now and to get it over with. And I think that besides this session we have two more, I think.
Yes,
two more, not including pre-exam session, if there will be one. And on Friday there's going to be some kind of a session introducing the different fields for the next part, for developers and QA and support, just introducing. I don't know if you know about this. I don't know if you're supposed to know about this. So there's going to be something like that.
When is that?
It's going to be this Friday, but I don't know if you're supposed to be notified about it, or maybe there'll be another one, or maybe it's divided into groups. Anybody knows about the session on Friday?
I've heard of it, but not on Friday.
Oh, so it's a legend going on.
A rumor.
Yes, urban legend. So yeah, let's talk about strings. We're going to see what are strings, you know, creating and using strings, you know, manipulating strings, most of what you're going to see here, you know, all kinds of other strings manipulations which maybe you haven't seen so far, but they're really quite straightforward, so there's not much to know about those, but we're going to see them. We're going to see the StringBuilder, I'm going to see formatting strings, and apart from the regular demos which are attached to this session, there's another demo which I showed in the previous part of the course when we were talking about console input and output manipulation, and there I also put a few examples of string formatting, and we're going to see that example as well, just to sharpen the examples of string formats. So we'll start with a short introduction of what are strings. You know, the strings are container of text characters. They're constructed quite similar to an array of characters, and this is the way that we are instantiating a string object, and we can initialize it directly with an assignment, and this will produce a string in the memory which will be constructed like an array containing those characters. Not much to say about that. It's managed by the framework, and it has its own properties that we're going to see, like length, and it has its own methods and its own static methods of the string class, as opposed to C++ strings, which are supposed to be terminated with a null, with a zero character, with a nothing character. In C#, all the strings are by default Unicode strings, and they can contain null characters inside them as well. What is the spaghetti monster doing here? I'm not sure. But if you don't know it, you better get to know it. Ah, spaghetti and strings. All right. The Pastafarian religion, yes. Personally, I'm a believer of the last Thursdayism, which claims that the world was created last Thursday, and it's recreated every Thursday, just in its current state. People with their memories, with their archaeological findings. Everything is created in its current state every Thursday. So the base class, or not the base class, the string class is defined in the framework under the system namespace. It's called, its official name is system.string, and it has, we can actually use the direct name. We'll see that it has the alias. We don't have to type system.string. We can use the string. Once we're using the system namespace, we can only refer to the string class name directly. And there is also a string with the lowercase s, which is an alias to system.string. So you can use system string, you can use string with uppercase, you can use string with lowercase. Everything goes with strings. They contain sequence of characters. We'll see the disadvantage of using a string directly, the immutable property of it. That means that every time you manipulate a string, or you concatenate a string, or you do some actions with a string directly, you are actually creating a new string in memory, and that's something which is not very performant and not very advisable, especially if your program is doing a lot of string manipulation. You better use something called a StringBuilder that will help you do it better. The string in C# and actually under the .NET framework are Unicode supported. In the other frameworks before that, for example, the C# language, were not like that by default unless you use some implementation of Unicode. And the .NET framework is supporting Unicode built in. Strings are stored in the heap. That's the place where all the reference types are stored, and that means that once we are finishing a code block, this memory is not automatically freed for us. So there is an action of the behind the scenes of the process called garbage collector, which is managed by the framework to clear this memory. And if you're doing a lot of string manipulations, you'll also have some leftovers there that will have to be cleaned up, which is also something that you have to take into consideration. And the strings are actually reference types, and that's why they're stored in the heap and not in the stack like direct reference primitive types such as integer. Okay, about this introduction. You can access directly characters of a string as if they are a character array. So here's how it's done. You have a string. We have a property of the string object which holds its length, so we can get it if we have, here we have an instance, an object, we can call the length property and we can read how long is our string. And we can scan it, or we can just directly go to one of the characters and extract it or read it as a character directly. So of course it's 0 based, so the index starts from 0 to 5 if we have 6 characters. And of course spaces are all included, and all the white spaces, everything is counted as characters in the string. Stand up, Balkan Superman. Okay. Is this from some song?
Yeah.
Is this Chalga? Okay. Okay. I think there should be more Chalga in those sessions. So here we are initializing a string. We are declaring it, and we are already putting a value to it and printing it out. I think this is all quite known to you. Using a formatted string here in the right line, we can print the length. So we'll just print a string s.length equals something, and in this something we'll put this parameter. And here we're going to scan the string from 0 to the length with a simple loop, and we're just going to print out the characters one by one, each one in a new line. Yeah, let's see this masterpiece. No, I seriously think that that most of what we're going to see today, you know. Next time, I think we're going to talk about classes and objects more, which is cool. And then we're going to go back to text files and texts and all that. First example. Okay, so seriously, there's not much to see here. Here's our string object, and here's its content. We can view contents of strings directly through the built-in visualizer of the debugger. So we are going to type out the string. Where's my, why can't I put it side by side? Maybe I can. No, I can't. Okay, so here we are here. We're going to print out, we're printing out the string, now we're printing out the length. Here it is. And now we're scanning each of the characters and printing out one by one. That's how you access them. We're printing out the counter, and we're printing out the character in the place like this. Is this unclear to anyone? Anyone with questions so far?
One question. Can we assign value with this construction index to string or not?
You mean set a new character?
No. You cannot.
No.
You cannot.
I think the characters of a string like this are like it said, read-only.
No.
And
So for me, it's not.
Where's my? We can try that like this. Yeah.
No.
Here's your exception. I was this is another one of the debug windows that can be used in order to run quickly statements. It's called the immediate window. You can reach it through, if you go through debug windows, and there's an immediate window here that will pop up. So what I was trying to do, right now we are in a breakpoint, so our code is valid and all our parameters are valid, and I was trying to run a line that takes the string in a certain place, which I know is valid, and assign a character here. And we got an exception that says you cannot assign a value. All right, more questions?
What about the new row? How much characters it brings? How much indexes?
What's the longest possible string?
No. I mean, when we are putting a new row in the string, it's possible to be slash r slash n slash r slash n and both.
You mean the string can contain line break characters? Yes, it can.
How much space?
Oh, I think each one of those is a character.
Yes.
Just
I
one
know
moment.
there is a book which
I think new line takes two characters.
two characters.
Yes, because
It
it has
depends
to put.
on where
It has
from
to
the
put
platform.
the. No, I think it does not.
in Visual Studio probably, but if you are working on Unix
I
or
think it's It
Or-
puts
I think
both,
each one of those is a
uh,
character.
both carriage return and line feed.
Mhm.
Yes, when you put n.
So it's two chapters.
Yeah, actually, there's a /n, there's a /r, there's a /t, but I think the new line really is two character.
Ice carriage return. No. Just return. I don't know.
CRLF. I'm not 100% sure, but I think the new line character takes two,
Yes.
and I think all the others are one character each. The specific one like tab, or there's a r/r, which is a carriage return, but it's not
It's
not a new line. Yeah. More. Oof.
What is the name of this one between two bracelets?
This one.
No, the one in the same row, just the one, the blue one between the bracelets.
This one.
Yes, what's the name?
This is for just code.
Yeah, this is a.
Okay, it's for just code the process.
It's probably
This. You mean what?
something
Just the
wrong.
one.
It's
This
probably
line.
not a character.
Yes.
No, this is not a part of my code. This is a part of one of our plugins for Visual Studio.
I know that
It is
it's part
probably
of
also
just
not a
code,
character.
but I don't know.
It's
Want to
it's a
know
drawing.
English word for this line.
Yes, what's the English?
I think I call
How
it.
to find it in studio and how to change the color.
Okay. I call it.
That us for me. In
Oh.
2 hours I was just for that.
For what? Or just code.
This
probably.
is.
I think
this-
this
This is
a
just.
component from just code.
Yes, I think it is.
There is a menu.
This is just code options. Okay, I'll have to look it up. But if you're asking what it's called, I call it the blue line.
It's called. The
But-
menu calls it structural highlighting.
Yeah, this is part of our helper plugins for Visual Studio that shows you which braces are related to which. So here I see what I call the purple line, and here I have two blue lines. So they connect for me.
Not a character.
Hmm? It's not a character.
No, I know that it's not a character. The problem is when you are changing the style, the visual style of Studio.
Yes.
I don't think it's built
You
into
need
Visual
just
Studio.
code to enable this.
Okay, I hear just code, but when I'm switching to dark pen,
Oh.
and then these ones they are dark, and I don't see them all the time, and it's kind
There
of
is-
problems sometimes. Especially when you're building something.
See here?
Your
you can
life.
set your colors
Okay,
here.
I know I can set the background, but I want to switch the color just for this one.
Well,
Your
yes.
life is
No, I
good.
mean, you can set the color for the lines here.
Okay.
Code
this one.
options, yes, just code options on visual features, structural highlighting.
I think we can see that
Each
later.
highlighting,
I was searching
Construct.
for it there. I
each
didn't
construct
find it.
has a different highlight color.
Look
Yeah.
at it later.
Okay.
But if this is your problem with everything we've seen, your life is good.
Well,
Yeah, just one thing I wanted to point out that we've also seen a few times is that you can also put a literal string with a.
What is
Yes,
Zengos,
with
I think it was called.
this symbol,
Monkey.
with a @ sign that will allow you to put inside your string, for example, slashes, backslashes,
Everything
spaces.
except
Yeah, and instead of putting slash quotes, you have to put two quotes in order to put a single quote in the string.
Yeah.
Makes it a little more flexible. Let's go on. So, as I mentioned, the class name, the full class name, if you want to be really correct, is system.string. So that means the class name is string and it's in the system namespace. That means you can either use system.string, or if you're using the system namespace, you can use only the string with uppercase. And there's also an alliance of string with lowercase. All three of them are good, just the same. Strings are by default nulls, unless they're assigned any value. You can do it through literal assignment, as we've seen. It could be from a variable, it could be directly hard-coded strings in your code. I think there's nothing more to say. Here's an assignment. So we have our string here. Since it's unassigned, it doesn't have a value. The default is null, just like with other reference types which are not initialized. Here we're assigning a value. Here we're assigning a variable value. And here we are assigning a literal integer implementation of the toString method, which we're going to see a bit later. We're going to encounter it again, but we'll see that all of .NET types implement by default the toString method that will take their string value. So in this case, we're taking the number 42 and we're calling it on the toString, so we'll get back a string containing the number 42.
Since iFormatable defines only the larger toString that on which takes format and format provider.
Okay.
Does that mean that this basically uses the bigger overload?
I'm not sure which overload it's taking.
Well, the interface was called iFormatable.
Okay.
And it defines only, the only two things it defines is takes string format and iFormat provider.
Yes, but this is when you are building your own formatting of your string object, and I think that this one that we see here is a more basic implementation. We can look at it. In any case, I think we're using this implementation of the object toString, not a format, not the iFormatable is probably implemented by specific types, and I don't think it's related to this implementation. And but not every type.
Everything has this.
Everything has this because everything inherits from object in the end. And of course, all the primitive types have their implementation. And if you have your own type, you can implement your own implementation of toString. And I think that if you take a class which doesn't have implementation of toString, it'll just print out the full name of your class.
Yes. Mm-hmm.
And we'll see more about toString later, but not much more. So just for now, these are the important examples.
So if you want to use this, you have to implement it yourself.
You have to override it in your own way, yes. The framework is smart, but not that smart.
Yes, and I think WriteLine uses the...
It just tries to call the toString, yes,
but
of the object.
Not the parameters, the other one.
Yes, the other one. I mean, again, once you are concatenating strings and you are putting an object inside a string, it will all be converted to one big string, and the toString should be invoked. And if you're putting it with parameters, like we saw when you're putting a console write line like this, then over here, there are many overloads of the console write line, which takes all kinds of objects, and they will be implicitly calling the toString as well. Here's something we've never seen: reading a string from the console.
Right.
Yeah, technology is amazing. And here is the way to write strings to the console. Great. Let's see a demo for the first time. I told you it's going to be.
Okay, let's make something harder.
Okay.
Just to make this. How we can implement some code so actually our string is executed in our program.
Ask it again, please.
We have a string and we want to execute it in our program.
What do you mean execute it?
Execute the
Oh, you want to execute a string as a code. You'll have to
have
use
to
some
use-
reflection. That's not
There
going
is
to
a
be.
class that's called C# code provider that you can use to
so we
This-
have to implement it ourselves.
No,
in
there
our
is
program.
there are tools in the framework that will allow you to do that. Partially, you can for example, parts of it parse it yourself in a way, and you can dynamically call methods and construct classes. Or there are ways relating to expression trees that you can use with strings that will parse expressions and will run them. The compiler itself in runtime, no. I don't think you'll be able
There is
to
a-
compile.
I think, well, I don't know, I watched some keynote about the unveiling of C
Mhm.
C# code, where
Mhm.
they did something, they sort of wrote C# interpreter.
There are tools for that, and there are classes that can help you with that. Depends on how deep you want to go with it, and really how complex your code is. It's possible sometimes through using reflection, and sometimes through using for example, I built once a project which had to start calculating formulas from strings, doing some mathematical arithmetic calculations coming from dynamic strings. So in this case, I used expression trees that can parse them and analyze them and build them into real expressions and execute them. You can do it. There are other tools and other ways, but it's not at the level of what we're doing here. That's for sure.
That's why.
So, how do you put it now in a way that it's visible? Like this. Here's a string write line. Here's a console read line. And here's a console write line with parameters. How awesome is that? Okay. Any more questions about hacking the environment?
It's not hacking the environment, it's useful. I think it's really useful sometimes. For example, you can name your variables like that.
You mean dynamically creating variables?
Yes, it will be really useful sometimes when you want to make some tests like random quantity of parameters.
You could use reflection for this, yeah. And this could be, for example, coming out of an array of strings.
Well, one thing, if it's something that you absolutely need, you can use scripting language. This is why scripting languages are so much more useful than those kind of things. I mean, if you need to
Okay, I see. I know that I can use it, but I was interested in C#.
Yeah, there are there are ways, or you can write a code generator that will dynamically generate your source files and then run the compiler and produce a new executable every turn, for example. Let's see some string manipulations. So there are a few ways in which you can compare strings. You can use the string static method compare, which will return a result according to these rules. It's a lexicographic comparison, which can be case sensitive or insensitive according to the last third parameter here. And it will return a result showing if the strings are equal or what should be their orders. So this is how it's done. You can compare strings directly whether they are equal by content. Either you're using the double assign operator, just like comparing any other two variables, or you can use the string equals method that also compares two strings.
With these two, does this mean that it overlocked its operator?
I think so, yes. As far as I know, using the equal sign or using equals is pretty much equal. Except that I think that equals have a few overloads with additional options that you can use instead of directly comparing them like this. Otherwise, as far as I know, there's not much of a difference between the two methods.
Does that equal count querying subclasses?
No, I don't think so. In the case of strings, these could be two different variables in two separate, unrelated memory locations, and what we're comparing here is the content. So yeah, and again, C++, everything is pointers to the memory, especially strings, which are by default character pointers, and then you have to know whether you're accessing a memory address or content of a string. In the case of C#, it's more simplified. So, an example. We have an array of strings. And we are storing the first string in the array in our own variable here. And then we are running through the array with a simple loop. Something to ask? Storing the current array element in a temporary variable in the loop, comparing the two strings, and once we have, if we have a string which is lower in its lexicographic order, we're replacing the previous variable with it, so that we're actually trying to find the string with the lowest lexicographic order. So we'll start with this, but then we'll replace it, and then we'll replace it, and until we get to the first lexicographic error. It's pretty much like doing a minimum value out of the values in an array of integers, for example. We'll see it how it works. So here is our array. It's unsorted. Here is the first element for now, which is the first one in the array. Now we're running through. We're storing the current element in temporary variable, running a comparison. Since V comes after.
Displace it. So
Yeah, it will just
it doesn't
displace
work.
this first town variable with a smaller variable, if it's the smaller value if possible to find. So right now our current town is Plovdiv, and it's smaller lexicographic order than Sofia. So it will be replaced, and then again until we reach, once we're out of the loop, we found the lowest one, the minimum lexicographic value string in our array. Cool? Okay. Concatenating strings. We'll see a better way to do that. But you already know that you can concatenate strings using the plus or the plus equal operator. So here we are, 3 strings, and we are concatenating them into one string, or we can just concatenate one string into another using the plus equals, or we can use the string concat, which is a static method of the string class, to concatenate 2 strings and return a 3rd string. And here we have an example, one string and one integer, which will implicitly be called with a toString here once we are concatenating them, and the result will be concatenated string with a space here which is added between them. And another example, again, 2 string variables, concatenating both of them and writing them, or concatenating them like this. Here we are also adding a new line character and printing them. So this will be the result of the concatenation. Yay. Yep. Not much to see here that we don't know. So here are 2 string variables, and here's the concatenated string with a plus, with a space, and now we're concatenating them with another string literals, which one of them contains new line and spaces and all that. We can see the constructed string here, which once it's printed, this new line character will become effective, and here it is. He's not 25. So far so good. I know you'll ask questions if you have them. Okay, index of and last index of, very useful methods which are used a lot because they are useful. Just finding an occurrence of a string in a string and telling us where in the string it is, what is its index, so we can search in our strings. And if we are for example, if we want to analyze a path in our disk, or we want to analyze a URL, if you're building something that works with, for example, browsing or any kind of HTTP module. Last index of is also useful, so we're searching for a string in the string, but from from back to forth. So we're searching for it from the end towards the beginning, so we can find the last occurrence if there are more than one. So an example, here's our string, this is our object, and here we are putting an integer variable, and we are calculating the index of the C# string inside. So since this is the first character in our string, we'll get an index of 0. Then we're looking for the word course, and we'll get the index of that. And of course it's case sensitive, so if we look for an uppercase course, we won't find it, and the index will be returned as -1, meaning not found. And other examples of repeatedly calling the index of. Once we have a specific index, we can start our search from the next index so that we are not repeating. That's how we can build a repetitive search in order to scan our string for all the indexes of a specific element. And of course it's 0-based index, so we're starting always from 0. If you receive smaller than 0, that means your string was not found. And this works the same way for index of and last index of. It's still working, right? Okay, here's our string. So first we're searching for the C#, and it's the first, so we can have the index of that. If we search for the chorus, it's on the 15th place. If we search for uppercase, it's not there. Here's the RAM. Here it is. And here's the first occurrence of R, so we can go on to the next one starting from 5. Here's the next one, and here's the next one. We could have replaced this one, for example, with a loop that will find all the occurrences for us. That would make it easier and more effective. Questions? Okay, another very useful method which is used a lot is the substring that can cut. Once we find an index, for example, of something in our string, we can cut a substring of our string. So we can say cut from this index to that index. So for example, we have a string here with a file name, and we are cutting a substring. Substring is a method of the string object which gets the first index to cut from and how long to cut to. And there is also an overload with one argument that says just where to start. So we'll start from that point and cut it to the end. So this is an example of, for example, if we have, like I said, a path on the disk, and we can find the last index of backslash, and then we can cut the last index substring, and we can get just the file name in this example. Or we can analyze all the occurrences of backslash, and then we can go through and cut substrings of our path and analyze that. So this is very useful when you're working with file names, for example. And that's all I have to say about that. So that's it. So here's our file name string, which is a full path containing the directory name and the file. So this is going to print out the full file name string. Now we're extracting the path. Let's step into this method and see. First of all, this is our character, which is set as a constant in the path class. So this is our directory slash according to our current environment variables. So we are looking for the last slash index in our file name. So this is our string, this is what we're looking for, and we got our index. We're initializing here the path variable that we're going to return. Since we found an index of the last slash in our string, we're cutting our string from the beginning to where we found the slash, and that will be our path, and that's what we're going to return. And here's the value. Extracting the file name, we'll do pretty much the same if we step into that. So we have the separator character, which is the same. We're finding the last index of the slash, but we're going to cut our substring from that index to the end. And here's the file name. Okay, since the index that we found here is of the slash, if we cut our string from here, we'll get it with the slash. So we have to go start from the next character, slash index +1, and we get just the file name, return it. Here's the assignment, here's the print, and the extension of the file. Again, we're just looking for the last index of point, the dot. So we found it. Here we are holding the extension in the beginning, and we're initializing it to empty, and if we don't find the extension, we'll return an empty string. If we do find the extension, which we did, I'm going to return it, assign it, print it out, and here's the output. Question? No. Oh. So that's a quite a real-world example of how these things are to be used, and quite simple, I think. Splitting a string, yet another very useful manipulation. Once you have a string, we can cut it down into an array of strings according to specific characters which are splitting them. So here, for example, we have a list of beers. It's one string, and we can cut this string into an array of strings by using the string split method. And the split method would usually be used with a specific character, with one character, but it also has an overload to receive params of characters, so it can receive a few characters at once, and it will split according to either one of the characters. So in this case, we're going to cut down this array by space, by comma, or by dot. And that means that every time we encounter a space or a comma or a dot, we're going to cut down the array into, we're going to ignore the character itself, and we're going to cut the two sides of it into elements in the array. So that's pretty useful if you have comma delimited strings and you want to cut them down into separate strings, and then you can analyze them Again, this is quite useful. So here we have a for each that will print out what we've created. So here's our initial string. Now we're splitting according to either one of the three characters, the empty, the comma, or the dot. Not the empty, sorry, the space, comma, or the dot.
Then it's going to create more strings than we need.
Yes, since we are putting, usually in this case, I would use maybe just comma to separate them. And I would,
Comma and space something.
if you cut by space, you'll get also,
No, comma and space together.
yeah, if you know that there is a space after each one.
But
You
then
know
you
the
have to
specific
use.
formatting.
If you know the specific formatting, it's easier. But
In split, can we use a string to split them? Because here we are using chars. But then
I think there is an overload with the
string.
with the string. So we can use params of characters and string separators as well. But since we're cutting the string here according to either one of those three, so we're going to cut it here, we're going to cut it here because there's a space, we're going to cut it here and here, so we're going to get all kinds of empty strings between those, and the result of the array, here it is, not just the names but also, so I would do it a bit differently. I would cut them by commas and then I would trim the string, the output strings, for example, to get only the names that we have without spaces.
But here it's working also because after that it's
yeah.
asking if there is a
Yes.
string. It's not.
Yeah, that's also an option. I think it's a bit of a excessive work here, which is not really necessary. But for the example, it's okay. So we're running through our array that we've created, checking if the current, we have a for each loop here, and we're checking each of the strings in the array. If it's not empty, we're printing it out. So we're ignoring the empty ones in our array. It's legit.
It's using a little bit more memory than it should be.
No, you're slowing down your for each here because you have to check every time your string instead of just cutting it and forgetting about
In
it.
the other case, you have one more loop, which is again the same.
Why?
Because that tool cuts the spaces.
No, I could. Well, one thing I could do is remove, for example, the last dots, which is something that I would. Let's see the other option. Let's put here. Let's remove this code. Oof, it's too much moving. Yes, all right. And now,
Can you do it in single loop? Or you can-
yes, why not? Like this. So I'm trimming out the spaces. One thing that I'm not trimming out is the dot. But I can, for example, try to do it like this.
Does it only work with one argument?
No, we have here a split that works with 3.
Yeah.
But it will cut down each one of them. So if we are cutting it here and here because we have a space, and then here and here, we're going to end up with just empty strings. I think it's a bit not
Well,
necessary.
You could do just the one if in your loop and it was going to be okay. One if you find the dot, you could.
Yeah, but then I'm going to have to do it every time I'm doing every time in the loop I have to run the if.
Check just the first.
So here I'm checking only that and trimming it out.
Okay, it's legit.
Yeah, it's legit. So I have one if here just to avoid the
There
last.
is no way to cut. There is just way to extract, not to cut.
I could do it with a split.
With the split, then it's too complicated. But okay.
Yeah, no, I could do it in one statement like this. And let's see if this really works. So I found the last character as dot. I removed it. Now I'm cutting it by, so I get only the beers, but they have spaces, and I'm trimming them. So I'm printing only 4 times and not going through the loop 8 times like before. And result is the same. I think a bit more effective in terms of programming.
So if there is a way to fix your stuff before the loops, fix that.
Yeah, if you have a loop and you are doing some excessive work inside every time your loop goes through, and you can avoid it, just run one statement here that will fix it for you. And otherwise, every time I'm in the loop, I have to start checking what I have, or trim it, or cut it, or if you can avoid that, make your loop more compact with less iterations and less work inside, that's better, of course. All right, let's go on. What's the time? Got a little time. Yeah, more manipulations which are useful and usable and used a lot. Replace, which replaces parts of your string with other strings. Of course, again, there are other ways to achieve this, and if you want to be more effective and if you have more complex strings that you need replacing, of course, it's better to use things like regular expressions, for example. But if you have a simple string like here, vodka plus martini plus cherry, somehow it always ends up with alcohol. So we are defining here a new string, and we're assigning it to the return of the replace call, which will replace all the plus strings with the word and. And that will be the produced output. And remove, another option that will cut your string into smaller and remove parts of it.
That's what I was asking for cutting. The last one is good.
Yeah, we could also have used remove. Could have also used replace. Replace the with nothing.
Those methods modify the object you already have, Or do they create a new object?
They create a new object, as far as I know. Directly working with strings almost always will produce new strings every time you're manipulating them.
Here it will produce three strings for removal. If it's in the middle, it doesn't matter actually where it is.
Yeah, and these things,
Three strings.
I mean, for you, the writer of the program and the user of the program, these things are quite transparent, and they're not felt much, but they're not very effective. And we'll see also an example of this, of how not effective it is and how it can be done more effectively. But every time you're manipulating strings, almost every time when you're directly changing, cutting, all these actions that we're doing now, you'll produce more strings in memory, and those will have to be cleaned up sometime, and it's not effective, not quite effective.
And that's because it's using array, not the list.
That's because that's how string object is implemented.
It's implemented as array of chars.
Yes,
This is
if you have an
arrays.
array of chars, you can manipulate your array, but these things in the string doesn't work by manipulation of the already allocated memory. It just takes what it needs and creates a new one.
In arrays, it's the same. If you want to extend the array, then you have to.
Yeah, extend.
Also, if you want to reduce it, it's the same. If you want to cut a piece of it, it's the same. It's all the same.
Yes, but you can also go to directly characters in the array and
this
change,
is the
manipulate
difference.
them.
And I'm interested why you cannot in strings.
You can assign a new string value to it. You can manipulate it with one of the functions and reassign it to the string that you already have. But every time you assign a string, you are creating a new string in memory.
So the basic question probably is, why is the thinking useless?
I don't know.
Yeah, how?
Maybe it was easier to implement and they didn't have time.
Yeah, but we can override.
Mhm.
We can override. That's it.
You can have your own implementation. You can write your own.
Or you could just use StringBuilder.
Yeah.
But StringBuilder, I was looking at it. There are some limitations.
It's true, but in working directly with strings is easier. But
It's easier. I mean, limitation is, for example, adding a new character between characters and in the same time keeping the string in the same length, the same.
You mean inserting?
It's too hard.
Inserting.
It's something like inserting, yes.
Why?
Inserting, but
we'll see some examples of we'll see some examples of StringBuilder as well. Okay, replace and remove, that goes from a specific index to a specified length.
Why? You can replace.
I know I can replace, but then you are not keeping the same length. Sometimes you need it.
How
For
so?
example, okay,
You
the
replace
simple
one
way.
character with another character and you have the same length.
No,
It's just-
I don't want to replace it. I want to insert something.
Yes.
You can manipulate in many ways. You just maybe you have to do 2 or 3 actions
Yes.
in your code,
You
but
can
that's
do
how
everything.
you
I
can
mean,
do it. It
you
it
can
will
append.
still be more
I know
effective to manipulate through a string builder. If you have a program which heavily works with strings, concatenating them, analyzing them, inserting them, rebuilding them, reformatting them, you better use string builder. Sometimes it's not the most comfortable way because you can just put 2 strings with a plus sign between them and they'll be concatenated for you and it's very nice. Many times it's okay, it's working like that, and I can tell you that in my work we do it a lot. We don't use a lot of string builders, but if you have heavy manipulation of strings and you want to be more useful and you want to be more effective, and you want your code to be fast and neat, and memory is important, then StringBuilder maybe not the best comfortable way for you, but once you get used to it, and if you need it, it's much better. That's
what you think you cannot do with StringBuilder.
I know I can do everything, but it's not so easy. Something.
Not as intuitive as using the string directly. I agree. Okay, two more very useful string methods, to upper and to lower. That will get them to uppercase or to lowercase. I think that's all I can say about that. Trim. We've seen trim. I just trimmed my string. So by default, if you call it with no parameters, it will just trim your string from spaces from both sides. If you want, you can trim other characters as well, and you can call it with any characters that you wish to trim out, and you'll get a trimmed string as well. That could be also used, for example, to remove the dot at the end of the string like we did. So we could have used that too.
But it's trimming just in start?
Yes, in the start and in the end. It will not reduce spaces inside your string, for example. Or you can use trim start and trim end if you want specifically just the start or just the end of the string. So in this case, we're removing spaces from the start of the string, so these spaces will be trimmed out and the rest will be kept. And that's all I have to say about that. Let's see it. So here's our first string containing pluses, and we are replacing the plus string with the end string and putting it into the replaced string, and here is the result. Here's the price string, which contains this number. Removing, actually what we're doing here is we have removed from the second we removed 3 characters, so we removed these 3. Yeah, that's what we got. Here we have alphanumeric string, and this is the result with to lower, and this is the result with to upper. Here's trimming spaces in both sides, and the clean string. Here's trimming all kinds of characters. Here's the unclean and the clean. Here's trim only from the start, the string and the clean string, and from the end, the result. Questions about this? So, as pointed out a few times, using strings directly, especially when you're concatenating or you're replacing the value of a string or manipulating the content of a string, you're every time creating a new string in memory. It's not useful, it's not effective, it can take time and memory consumption. So, for example, here we have an example of concatenating a string. Specific character is going to be reconcatenating again and again for as many times as we need, and we're doing it directly with a plus operator. this thing will not be very effective. Yeah. If you're doing something like this, like I said, if you have code that heavily manipulates strings, try not to use strings directly. It's not advisable.
Here we can use StringBuilder, and after that again cast it to strings.
Yes.
We have string again.
Yes, you can use StringBuilder and you can do append and
But
append
just
and
inside
append.
the method.
Yes. I mean, again, the implementation will be that you'll have, like you said, here will be a string builder instead of the string of the result, and instead of appending them like this, we'll call the string builder append method, and in the end we'll get the string builder, the string builder's build string returned, and that's it. The result will be the same, only better.
In the input also it is.
The input and the output will be the same. Just this is a classic example of how methods could be improved, and they still stay as their own black boxes. They have their same signature, so that means whoever uses this method will keep using it the same way, will get the same result, only much more effectively.
One more thing. When we are writing a method, how we can note it? I mean, most of the system methods, they have notes. What is it? How we are using it? With each character for what it is.
I'll show you.
You
Good.
mean documentation?
Yeah,
Yes,
it is
for
documented.
documentation.
I'll show you. I don't know why this picture is here, but let's. It's a bit depressing. I'll show you how to document this method. So here we have the same method, the ineffective one, that is going to duplicate a character by concatenating it into a string time and time again. We're going to do it first 50,000 times, and then we're going to do it 200,000 times. So we're going to see the effect of that. We're going to write the time before and after. We're going to calculate how much time this took in milliseconds, I think. Let's just run it. So the first one is finished. The second one still going.
That method with date time never worked for me. Time in execution.
Oh,
I don't know why.
You can use stopwatch.
Yes, I use stopwatch because date time never worked for me. I don't know why.
maybe our methods are too fast. And okay, finished. 25 seconds. Yeah, quite a lot for just constructing a string. As you were asking about when we're writing methods, it's
Let's start with StringBuilder first. Just
yeah, we'll see it with StringBuilder. The same execution. But since you asked, and since it's quite important to notice this, if you're writing a method, it's important to document it and to explain what it does. The Studio has an extension that does that. Once you put above your method, you're typing 3 slashes,
Yes.
and it will fill your data. Here you can fill what this method is doing, what this character is for. Here is the parameter with the ch, parameter called count, what it returns. And when I'm using the method, I will see my comments. So here is what the method does. Here's the first character, what it is for. When I go to the next argument, I'll see what is this count for. There is an extension for Visual Studio called GhostDoc, which when you use it, it has a shortcut key, and it analyzes your function name and your variable names, and it prints out a much clearer already messages, so it can understand, for example,
Telerik,
no, No. It's a free extension that you can download for Visual Studio.
No, I don't think it's even an extension. It's just
It's an add-on. It plugs into Visual Studio. Here. And it's much more useful.
what? Looking tools?
Yes.
Oh, wow. I don't have it and I still have this feature.
Maybe it's a different extension.
Oh, it looks exactly the same.
Can you try?
Hmm?
Can you try? So I can see.
Yeah. Here's the output. It's putting the same structure, but it analyzes the name of the method, and it also, for example, if this would be with a more understandable name, like character to manipulate, it will be writing here the character to manipulate. So it's much easier to use. If you're documenting your methods, it's very recommended.
Could this be before the definition of the method, or it could be inside the definition?
No, it's usually put before, like this.
And after you write your method, because
After you have your method, actually, once you put the method signature, then you can already add it. Then you can fill your method with content.
I think this is intrinsic to the C# editor in Visual Studio.
It is if you use 3 slashes,
Yes, exactly.
but it's empty. And Ghost Dog fills it for you with significant data. Saves time.
Okay.
So, system text string builder is the class for string builder. Here's the same method that we've used for concatenating strings. Actually, no, it's going to reverse a string. So it's going to run through our string, and it's going to build us a string from the end of our string to the start by appending characters. So one very common method of string builder is the append, which does exactly what you do with concatenating, either with concat or with plus sign, and does it in a much more effective way. So string builder works with the memory buffer and doesn't really create a new string every time. So it keeps your objects, and it's much more effective, as I've already mentioned many times. You can also allocate it with a specific buffer size if you want. You can access specific character values inside your string. You can still get your length of your string, just like you're using a regular string, just everything is done better. You can append to a string, you can remove from a string, you can insert to a string, you can replace a string, just like you're doing with a string, just does it better. And the toString will return the contents of your string builder, whatever it has contains, whatever it's built. So another example, we got a string here, we have a string builder, we're running through the characters, so we're checking, here's a method of the character class. We have a static method is upper, so we're checking whether the current character in our string is an uppercase, and we're appending it to the result if it is. So we're collecting all the uppercase characters, putting them in the result, and returning a string. So the user of this method knows that he's sending a string and returns a string. Doesn't know how it works, but the implementer can do it with string builder and get more effective code. Here's a bad example again, taking two strings and concatenating them. We can do it with string builder, append, And we're starting with an empty string builder, appending the first, appending the second, and returning the toString. So as I already mentioned, once we're doing a concatenation in this way, we have several objects created in the memory. They'll have to be collected with the garbage collector because they are in the heap. And if you're using them in a loop, as we saw, it's not very effective. And we'll see how StringBuilder is better. So we have a few examples of methods here that use StringBuilder, like we saw. And we have the duplicate character method that we saw with that took over 25 seconds to complete. Only that we're doing it now with StringBuilder, and we're going to do the same 200,000 times repetition.
Only one chapter. The other one is
With one. Same.
In the example, it's with CH.
Mm,
What is this example in the
yeah,
presentation?
in the presentation. Okay. That's cool. So here we have our string. We're calling reverse it. Here's the method. It's going to run with a string builder, and it's going to run from the end, from the last character to the first character, and just append the characters in reversed order. Let's step out, and the result is this. Capitals again. We have our string builder. We're running through our string, checking the character, whether it's an uppercase character. This one is, and we're appending it. If it's not, we're skipping, and in the end we'll return the result with the toString, so we'll get whatever the string builder has built. Let's step out, and here's the result. And for this one, I'll just put a breakpoint in the end here. We'll let it run 200,000 times, and that's it. And that's the time it took in parts of a second. Yeah, quite much more effective. We can run it again. Put it here. Run it again, and we're finished. So that will be a lesson to you all. Before we start formatting strings, which I think is our last part, but if anybody wants to freshen up before we're losing the cafeteria, now is the time. So let's take a few minutes break, refresh, and finish up. One more thing that I wanted to point out, a very useful method which was not mentioned. Once we have a string, there's a method that returns is null or empty of a string that will tell you whether your string is null or contains an empty value. That's quite useful if you're manipulating data. And the string also has, it's not here, why? Why not? I'm missing one method, which is called is null or white space. Yes. System string is null or white space. Okay, I'm not sure why I'm not getting it here right now, but there are two methods which are very useful. One of them is null or empty, and the other is null or white space, which for some reason, probably because of the references of this project, I'm not getting. But they will return you true if your string is empty or null, or it only contains spaces or
don't
line.
have to check basically.
Yeah, and if you have uninitialized string, or if the user hasn't entered anything, or it's currently still null, or it contains only white spaces because the user just typed with the spacebar, it will all be returning true, and that's quite useful.
No or empty.
There's null or empty, and there's null or white space, which contains null, empty, or just white spaces in the string. Very useful. Okay, what we're going to see now in the last part is also something that you already have seen countless times.
I think it was
Is null or white space in one word, yes. So, as we've mentioned, all the classes, because all the classes in the .NET framework inherit the base class called object, and this object class has a virtual method called toString. That means all the classes in the framework have the toString method. Should return a human readable, culture sensitive string representing the object. So if you have an object, for example, representing a person that has a first name, last name, age, you can build your own toString method that will return representation, textual representation of your object. If you don't implement it and you have some kind of class, this method will return the name of the class by default. If you want something more, you'll have to override and implement it yourself. Most of the types, the primitive types in the framework, have implementation of toString, and it's implicitly used when you are concatenating or when you're using writeline. You can also explicitly call the method. So if we have a number here, an integer, we can explicitly call number toString, and it will convert it into a string object. So here we are actually printing out a string and not a number, but we could also put the number and it will get the same result because toString will be invoked. Formatting. We've seen all kinds of examples of formatting strings. For example, once we have a number, we can return its hexadecimal value. Or if we have a number, we can get it into a currency format. And in this case, we got the number, or we can get it into percents format like this. Or we can get it formatted in specific decimals size. So these are examples of formatted strings that can be put in the toString method to format your output. These can also be used when you're using directly with console writeline in order to format your strings. So there's a whole lot of those, and they're quite useful. They can give you margins, they can give you number formatting. I'll show another example on top of what is demonstrated here. But we'll see, I think, those also. There's not much to say about those. They just take a string, and once we call toString, we can also apply formatting parameters that will be analyzed. Formatting strings is pretty much what we're doing in every console writeline. We have here what we can call a template, which contains those replacement placeholders, and we can call string.format, and it will take our template and replace the first one with the first parameter and the second one with the second parameter, and pretty much the way the console writeline does that. This is quite useful, by the way, especially if you're building, for example, a multilingual system. And once you want your strings to be translated to another language, you can build templates which will be changed by the language. And so maybe we need a different structure. We're placing those in different places of the string every time. So it's not good to just take things and concatenate them, because the whole meaning of the string needs to be kept. So you can build different templates with different languages, and wherever you put your replacement arguments, they'll be replaced with whatever you need in the right place and construct a string again. And we'll have to call string format with a different template, but just replacing the right variables in time. Here's another example, string format. So we're using the same template, but we're replacing it with different arguments. So that's how you can build different strings, keeping structure quite easily. If you have a placeholder in the string, you can format them with specific width and specific formats. Again, these arguments, there's a whole list of them and how they're used. For example, here we're taking a number and we're replacing it with hexadecimal value. Here we're putting the decimal value. And we'll see these numbers are 0 and 1 are the placeholder numbers. So this is the first argument and the second, and they are being reformatted.
Can we use both classes take only the first argument?
Yes. You can repeat the first argument as many times as you want in the string. It will be replaced again and again. If you have a datetime object, there's a whole list of arguments that you can use in order to rebuild your time and date string. So you can replace day with a short version or longer version, or month with 2 characters or 3 characters, or year with 2 or 3 or 4 characters, and minutes and hours. So basically you can take a datetime object like this one here, and you can put it here as a replacement argument and build your whole format as you wish. Also quite useful. Let's see a live demo and then maybe another live demo. So let's follow the strings. 42. So we have a number here, and we are formatting it into a decimal into 5 spaces. So that means we're going to take 5 characters, and it's going to wrap it with the zeros as needed, up to 5 characters, and that's the result. Convert it into hexadecimal, convert it into currencies. That's my current culture, which is set to American English, so the currency of this culture is US dollars. Formatting it as a floating point number, and the result with 2 spaces after the decimal point. Formatting it with 10 points after the decimal point. Formatting it as percents. Now we have our template string that will replace 2 arguments. Here's one replacement, and here's another with the same template, and now we're taking a number into a formatted string and putting it into setting spaces around it. So here's one example and another, and printing it twice as decimal and hexadecimal, and printing out a datetime string, and here is the result. The decimal, the hexa, and the datetime. The last thing I wanted to show, unless there are questions about this, is a more elaborate example which I showed in the previous part of the course when we were talking about console input and output. I gave another example of string formattings just to take a look at it. Don't need this.
I remember that.
Yeah.
And I'm using it.
Okay, good. So here we have a long string and a short string, and we can see that we can call the string, we have a method called pad left or pad right, and we can pad it with spaces as we need. And here, what we're doing here actually, since we're padding it with the same number of spaces and placing it in the same format with the same width, what we'll get is padding it left and right, but we're actually keeping the same structure with the same width on the screen. So that's quite useful.
We can center the text also with some formulas.
Yes, you can also. Yeah, we've also we
But
we
then
did that.
there was a problem with odd and even chapters because console doesn't
Yes.
get how.
Because if you have an even number of characters, there is no middle.
Yes.
So here we're doing the same effect, but we're using, instead of using the string pad left and pad right, we're using the formatted string options that we're giving it 20 characters width padded, and this will put it to the left side or to the right side, depends on the number that you're specifying, if it's below 0 or above 0. So here we have the same effect, only in red. Formatting decimal numbers. So here we're going to have a yellow example. So we have our long decimal numbers, and we can choose how it's formatted, with the dot, without the dot, what's the maximum numbers that we're putting, whether we're rounding it or not. So these are all examples of formatting the string, or for example taking a phone number like this and formatting it character by character into the screen, splitting it with spaces, adding your own characters into that. As an example of what you can do, so we have the number, we can put it with 2 decimal points, we can put it with 2 decimal points whether we're rounding it or not, a maximum of 2 decimal points, a minimum of 2 decimal points, taking the phone number and formatting it as you need, with 1000 separators or without, which is done with this notation. Taking a number, for example, again we have a floating point number, we can take the whole part of it and we can take the second part of it. So once we have a decimal number, we can put in separate places the whole part and the decimal part. So I'm taking the whole part in one side and the decimal part in the other side, and I'm putting my own string inside. So this is a good breakdown. All kinds of examples of using datetime formatting. So once I have a datetime object with a specific date and time, I can extract the year in different ways, the month in different ways, the day in different ways, the hours, the seconds, everything we need. So these are all the particles that you can use to format your own datetime string. And the last part is not really about string formatting, it's just console manipulation of putting your cursor at a specific position and retyping a character, so it produces some kind of a counter.
Also, I was going to ask you, is there some kind of backspace for console cursor?
Oh, I've never used such. You mean to create a backspace that will shift all the content of the console?
But not on the same row. It doesn't. If you insert a new one, then it will backspace the last one.
I'm not sure there's a built-in option for that.
And the other thing, maybe we can show how to build a string with same character, different length. It's useful for ones and this kind of things. For new string,
There is a
character,
constructor for this.
Yes, it's a constructor.
Mm.
One of the other nodes has this option.
Yeah, like this.
Yeah.
It's useful for ones and this kind of things to separate the code in the console.
Well,
And this will run faster, I think. The last example with the loops.
yeah, you're probably right about that. Oh, now we have to wait. Should have put it.
I made the same one, but in the center of the screen,
Mhm.
it's bigger.
Great.
It's one of the tasks I did was something like that to make something count.
Hmm. So, yeah, could be useful.
To make one,
Mhm.
I mean, to separate, for example, one task from
Yeah.
the other in your console.
Hmm. So you use this?
I use it, but with one, not with A.
Okay, like this.
Yes, like
Before the countdown, maybe.
Before the countdown, let's put it as the first statement.
And also you can directly print it with right one even without taking some variable.
Of course.
You can just make on the right one, you see in the bracelets new string.
Because yeah, once you have a console call, you can put any string you want, and other types of course as well, like we've seen that you can put, for example, an integer. But any string that you put here, either literal or a variable,
You can
or
even write new string here.
yes, of course.
Yes.
That's how I use it.
Oh.
There are more public characters, probably, like a box. And
Yeah, you
something like that.
can use any character you want. So
For the thing you're using for.
yeah. So that's what I wanted to show, just a few more examples of string formatting. If you need to format a string and you need to format numbers or dates or times or put spaces or format your decimals, there are many ways to do that, and there are many examples of this online. Perhaps maybe I'll share this project, which I think I didn't last time.
But if we just want to erase, then we have to add spaces after moving the cursor back. Okay, in the most cases we know how much space exactly we write it in.
Yeah.
In most of the cases we know, because for example we use some right one or something like that.
Mhm.
So we know how much we have to get the cursor back. And then we have to make some white space or space and again go back.
It really depends what you're trying to do. I mean, for example, here to replace the counter, every time. I put it on a fixed width, so it's always replacing all the spaces and around it. Otherwise, I'll have leftovers. When my string becomes shorter than 3 characters to 2 characters, I'll have leftovers. And that's not nice.
If you tables in console, you use this.
Yeah, you can use this, or
So everything lines up properly.
you can also, if you are into that, you can go back to the example of the Tetris that I've provided in the previous.
There you are erasing it, but like I said.
Yes,
you are
because
moving
it's more manually
your
done,
manually.
because we are. So this is the console Tetris game that uses strings, basically.
Yes, it's moving the next row, and erasing the previous
Yes.
one.
That's it. Okay, any questions about string formatting? And, yeah.
I think about when we assign a string and we put some formatting, and then we format again, do we change the string when we put formatting, or it is just formatting about the value of the string when we put formatting? Do we change the value, or it is just
You mean in the case like we've seen here, you are returning here a new string variable. You are creating a new string which is formatted as you have specified.
Yeah, for example, with the 42 letters in the currency, this
You are
is
not-
just string, and then
You're,
can
you,
notes.
yeah, this string is not changed in this case.
It's even integer, it's
Hmm?
not string. It's not string, it's integer.
But it could be a string. Yeah, in this case it's a number, but it could be a string that we are reformatting.
It's to string and formatting.
Well, you can use string.format in this
But
case.
then some of the things are not going to work. For example, this with the floating point.
You can use it with string format. Yeah, that's true, because the floating point number is being parsed in this case. Yeah, as a number.
And with the date option also.
Yes, because it's using the properties of the datetime object. That's correct. But
I have a question. Can you know a bit more about regular expressions? Quick overview.
quick overview.
Quick overview of regular expressions.
At 8:30 in the evening. Quick overview of regular expressions. Yeah.
Well, I know a joke is a very good overview.
Yeah, quick overview
You have a
will
problem?
probably take
You decide to use
really
regular
problems.
expressions.
It's ours.
Now I have 2 problems.
Okay, who knows what regular expressions are? Yeah, quick overview will be just
the best.
right. Okay.
I use them quite a lot, actually.
They are useful, but regular expressions are strong tools for manipulating strings, basically. You can. They are very powerful if you need to find instances of strings inside strings, for example, but not doing it like for example, like we saw with replace, which was just taking one part of the string and finding it and replacing it. You can have them much more flexible to find sequence of characters where the first character is a lowercase and then you have as many spaces as you want, and then you find another uppercase character and you take this whole thing and you replace it with something else, or you extract it. You can find in your string patterns and you can find the repetitions where they match, and then so this is a very, very powerful tool. And of course the framework has its own regular expression class that can be used for these cases. I recommend no, this. There's a nice tool. Not this one,
I
I
recommend
think.
regex buddy.
I don't know that.
I don't know if you know it.
This is a very nice online tool that can take a string and find occurrences in regular expressions, and it will build your regular expression that you can use. And it also has a help here. So if you're putting in a regular expression, for example, /w, it will match any character which is not a word character, under alphanumeric or underline. If you put a slash with a capital S, any character which is not a white space character. So you can really build, for example, if I have a string and I want to make sure that it's a valid email address, I can build a regular expression that will validate if it's an email address. So I have restrictions about the first part of the email address, which would be a name. It should be starting with an alphanumeric character or an underline. And I can then find that I have the @ character inside. And then I can find that I have the domain with a dot. This is the address.
I recently found a page with a whole slew of regexes for parsing different addresses,
This is
email addresses.
there are many ready-made expressions that you can use if you don't want to reinvent the wheel and not to make mistakes.
None of them did it.
Yeah,
100%.
they're not perfect. But just explore the regex class, and you'll see many examples of how these are used, how the matches are found, and if you want to construct your own regular expressions, start with something like this. There are little booklets with explanations of all the possible combinations inside regular expressions. There's one nice book by O'Reilly, which I don't remember its name, but it's a small booklet which contains them. But I don't know if you're going to deeper than this run into regular expressions, but they are strong, very strong string manipulations. They are useful, they are efficient, and they're a part of every programmer's life.
There are also different syntaxes.
Yeah, that's true,
Different conventions.
but there are many ones which are standard over most
the
of
most
the...
popular is based on Perl, I believe.
Yeah, so it seems.
And for everyone who wants to really dig in regular expressions, they can look for a tool called regex buddy. It allows you to build your regular expressions in a graphical user interface, and it also allows you to debug your regular expressions.
That's the first time I see it.
Yes.
But yeah.
You can debug them also.
Mhm. That's quite a tool. So, yeah, I don't think we're going to dig deeper than this right now, because of the late hour and because of the heaviness of this topic. And I can assure you that whenever I encountered regular expressions, and I have encountered them quite a few times in my professional experience, they are much easier to build than debug. Once you have to start understanding code which contains regular expressions and what they're supposed to find in your string, it's much more difficult than to write an index of or replace something. They're not easy to, because of their structure. For example, here's a regular expression to find an email address. It would look something like this.
Is that some kind of loop around? No, never.
So,
yeah, this even doesn't even contain lookarounds. This one.
It's a simplified.
yes. No, I'm sure that if you look at something like email address, you'll find something much, much bigger. Regular expressions.info. No, that's still
Very simple.
very simple. I've seen email regular expressions.
Well, search for the maybe negative loop behind, and you'll find something that's not so simple.
Yeah, maybe here in Stack Overflow somebody gave a better. Oh, something like this.
Yeah, that's nice.
Try to debug this. So this is part of the RFC. This is really the standard way that an email address can be parsed.
Yeah.
And you tell me.
Escape characters, non-capturing groups.
I don't know. There are a few times where the and at character is appearing, so I guess there are quite a few options here.
I don't see.
Yeah, I don't see a problem with this one.
You don't see a problem.
It looks okay. Oh, this one should have been a semicolon. But yeah, dig into regular expressions if you want. They're very useful tools, but we're not going to look deeper into those.
However, this is not a free tool.
Okay. So I'm sure you can find a free version of it if you know what I mean.
Yeah. You're invested, you know.
Well, not in mega
Site.
uploads, but
That's quite the joke.
yeah. So we've looked into strings again today. Seen some things, very few new things, I think. These methods that we've seen, the index of, last index of, substring, replace, remove, upper, lower, trim, very useful methods. Mind you, the StringBuilder option, if you're really doing heavy work with strings. The toString, if you want to represent by text your classes. Format for formatting everything. I think I'm going to share this little project with all formatting options, even though you can find these samples online everywhere. And I think there's not much more I can add, unless there are any questions. Okay. So we're done with this part. And